All right. Hello, everyone. Thank you so much for being here. My name is Abby. My pronouns are she, they, and I'm a recruitment specialist in the Faculty of Engineering. And we're so excited to have you here for our Environmental and Geological Engineering virtual Ask Me Anything. You can submit any questions that you might have using the Q&A button at the bottom of your screen, and we're going to respond to those either through typed responses, or we're going to save as many as we can for our moderated Q&A, which will happen after the presentation. And if you have any questions, either that we can't get to today or any that come up after the webinar, feel free to email us at enginefo@uwaterloo.ca anytime. Before we do get started, I want to do a territorial acknowledgement. So the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the Nutria, Anishinaabe, and Haudenosaunee peoples. Our main campus in Waterloo is situated on the Holoman Tract, and that's the land that was granted to the Six Nations, including 6 miles on either side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and all of that is centralized within the Office of Indigenous Relations. We encourage you to visit nativeland.ca to learn more about the land that you occupy, wherever you might be joining us from today. As I mentioned, the bottom of the screen should look something like this, and you can submit any questions that you might have using that Q&A button. Closed captioning is also available by clicking the CC button, which should also be at the bottom of your screen. And you can email engineinfo@uwaterloo.ca with any specific or additional questions after the webinar. We have lots of great panelists on the call today, including Jen, who is our Director of Geological Engineering, Bruce, who's an Associate Professor within the Department of Civil and Environmental Engineering, Kasturi, who's a fourth-year Environmental Engineering student, and Jeff, who's a fourth-year Geological Engineering student. So they're all on the call, happy to share their experiences and their expertise within these fields and give you a little bit of insight into what environmental and geological engineering is all about. So without further ado, I'm going to hand it over to Jen.
Great, thanks, Abby. So first of all, I just want to thank everyone for joining us tonight. We're all really excited to talk about our geological and environmental engineering programs here at Waterloo. So thanks for spending your Thursday evening with us. So before we kind of get into the details of some specifics about, what geological and environmental engineering is, I'll just quickly explain how they're connected and a little bit about how they're different. So geological and environmental engineering are all disciplines of engineering that help us sort of construct things in the natural world in order to sort of let us as humans live and enjoy the world that we live in. But how they're different is kind of where it is in the world or where it is in the larger environment that you're actually, solving problems or, say, building infrastructure. So you'll see we've got two circles here that are connected. The way I like to think about these two connected circles is where they're connected, that's the surface of the Earth. And if you kind of go from the surface of the Earth, if you think about what's underneath your feet, you've got some, today we've got snow, but generally you've got sort of, some soil, and then we've got rocks underneath that. That is generally the world of geological engineering. So anything to do with sort of that snow melting, seeping into that soil and then seeping into the rocks is the world of geological engineering, as well as actually, building in rocks itself. Environmental engineering is when you're going from that sort of surface of the world, so dealing with that soil and that snow that's melting, but then sort of going up into the atmosphere. So both geological engineering and environmental engineering are both working to do things like, help deal with the climate crisis that we're dealing with. And both are engineering things for the human world, just sort of where it is in our natural environment is slightly different. So that's sort of the two different disciplines. And I'll spend a little bit of time just talking about geological engineering, and then I'll pass it off to Bruce, and he'll talk more about environmental engineering. So when it comes to geological engineering, I mean, the name kind of gives it away. When you're a geological engineer, you have to understand the properties of the Earth. And that's either because you are building in the Earth, on the Earth, or with the Earth. or you're trying to solve some sort of problem, perhaps that the Earth has kind of created. And I'll talk a little bit more about that in the next slide, but if you can think of it like a landslide, that is an Earth-based problem, and geological engineers can come up with solutions to making sure that landslides don't take out towns and highways and things like that. So really understanding the Earth is really important for geological engineers. And this is really a rapidly growing field for a couple of reasons. First of all, because, we all want to, it's very important to think about environmental stewardship. We want to live in a sort of a cleaner, safer, better world. But we're also dealing right now with this climate crisis. And so not only do we have to build environmentally responsible solutions to engineering questions and things like that, but also we want to make sure that the way that we do things is going to be keeping humans safe. So a lot of safety has to do in human safety in geological engineering. So the different kind of things that geological engineers sort of actually do is, first of all, they help to design safe infrastructure. So infrastructure is basically all of kind of like the built human world around us. The easiest examples to think of are things like highways and railways and pipelines and things like that. And if we need to build a highway out in BC going through like the valley between two mountains, we need to make sure that, first of all, when we design that highway, that it's going to be stable and it's going to be safe. So meaning, it's not going to, trigger a landslide, or if there is a landslide, that it's not going to take out that highway. So designing a safe infrastructure for humans, but also making sure that what we're building, so that highway has the least amount of environmental impact on the natural area. And also deal with a lot of developing energy and natural resources. So going forward in Canada's green economy, if we are all going to be driving around in our great little electric cars, we need batteries. And so there is going to need to be some responsible resource extraction in order to move towards this green economy, and geological engineers can help with that. Other kinds of resources that geological engineers deal with are also things like groundwater. So making sure that we have safe drinking supplies. So we want to make sure that, if we put, let's say, like a gas station somewhere, that if there is a leak of that petroleum, that it won't get into the groundwater. But if it does get into the groundwater, how do we clean that up? And then something I've touched on a couple of times is this whole idea of sort of, like I've said, landslides a couple of times, but doing geohazard risk assessment, and also making sure that the human world that we build is impacted the least amount as possible by things like landslides and earthquakes and volcanoes, is also within the realm of geological engineers. So lots of interesting things that geological engineers get to work on. And so question is, how do you get there? What do geological engineers learn? So essentially, geological engineers take foundational engineering courses, so they can learn engineering skills to build up sort of this engineering toolbox. So they know how to attack engineering design problems. But they do that all within while taking earth science courses as well, because the Earth, as I've mentioned, is that sort of the world that you are going to be designing and solving engineering problems in. And so at Waterloo, we do have quite a bit of lab-based courses, or labs are very important parts of courses, meaning you're always going to be getting sort of like hands-on experiences, like actually, analyzing soil, analyzing rocks, analyzing that groundwater. And a lot of that will be things that you might actually do out in the field. And we actually have several sort of longer field courses that you can take as well. And really these sort of lab and field experiences are really meant to be sort of bridging kind of what you learn in the lectures, so in your classrooms, to what you will actually be doing as a practicing geological engineer. And also so you can actually see those processes that are happening on the earth kind of on a first-hand basis. So if you like getting your hands dirty, this is definitely the field for you. So when it comes to the different courses that you take, you can read these course names, but essentially that first sort of part there, the core engineering courses, that's when you build up your engineering skill sets in order to be able to solve engineering problems. So you'll take a lot of different sort of math courses, so sort of like math and mechanics courses and things like computer modeling, so you can learn how to solve engineering problems and make good design suggestions. You also do that while taking those earth science courses. So you'll learn a lot about minerals, a lot about structural geology, so how rocks like to deform and fault and things like that. And when you put those two together, that is what makes you a geological engineer and not another kind of engineer. Within our program, so everyone, when you come to Waterloo as a geo-eng, you'll get a geo-eng degree, but you have some areas that you can specialize in. And usually you kind of do this after taking the first year or two of courses, and you'll have sort of a good idea of what kind of specific types of geological engineering you're interested in. And from there, you can pick your courses in order to get some specializations. So there's a specialization in geology. So think, rocks and minerals. Hydrogeology is another one. So that's sort of like more related to groundwater. And then we have a third specialization in soil, rocks, and structures. So those are all specializations you can get with a geo-eng degree. And then there's also some larger options you can get, and these will be similar between geo-eng and enviro-eng. So these are ones that are offered to any engineering student. So you can get options in AI, entrepreneurship, some life or physical sciences, or management sciences. So really, you can take a lot of different courses, and when you get into upper years, you can really specialize your degree. So you can take the courses that you're interested in and get sort of that value added to your degree by getting the specialization or an option. And then once you've actually got your degree, so you've got those, maybe a specialization and an option, and you're in the working world, what do or where do geo-engs actually work? Quite a lot of our students who graduate go into environmental and applied earth science consulting. So these will be when you're working for a certain client, usually trying to solve a certain problem for them. So let's say that, maybe you're out in BC and maybe you're going to be working with someone who wants to put like a pipeline through a mountainous area. Then you can do geohazards assessments to make sure that that infrastructure is not going to get damaged, but also, once again, to make sure that pipeline has the least amount of impact on the environment as possible. So lots of different consulting opportunities with geohazards, groundwater resources, or contaminant remediation. So if some sort of like pollutant does get into the earth, so you can go and clean it up. A very growing field these days is the world of sort of this green energy and also geothermal energy. So we have a lot of our alumni that go into industries revolving around that. You can go into what I would say is maybe more of a traditional route, where you can go into like mining and resource exploration. It is really important that we still responsibly extract resources to help our new green economy, and geological engineers are well suited to do that. We can also get students who go into some sort of municipal or provincial government, and then also some stay to do grad studies or go somewhere else to do grad studies. So we've had students that have done, masters in engineering, but also they can go on to do MBAs. We've also had a few students go into law, and just recently I wrote a letter of recommendation for a GeoEng who's going into medicine. So really the world is your oyster, so to speak, after you graduate with a GeoEng degree. Lots of options are out there, and our students are they usually have a job coming right out of fourth year, and usually they're just getting snapped up by employers because this is a very important and growing field. So I think that's all I have to say for now. I'll be super excited to answer your questions later. Now I'm going to pass it over to Bruce, and he's going to talk a little bit more about environmental engineering.
Great. Thank you, Jen. Yeah, I'm here representing environmental engineering. I'm an associate prof in the department working in the field of kind of water resource engineering. So what is environmental engineering? We've heard a bit from Jen. I like to think about it as working at the interface between human and natural systems. So wherever there's a need for us to get a resource or something, or whether there's something that we're putting back into the natural world, there's a need for systems and people who understand both sides, right? So we kind of have dual responsibilities. One is we want to design systems to better human health. So for example, a water drinking treatment plant so that the water we have to drink is clean, but also ensuring the resilience and health of the natural systems we depend upon. So that's the other side. That's the wastewater treatment part where we're putting the waste back into the natural world. We need to make sure that it's clean and not going to damage the ecosystems on which we eventually rely, of course. So there is an urgent need here. People, I'm sure, are aware of this. These are just a few photos from stories in the last year or so. So there's an urgent need to develop people, but engineers specifically, that are able to solve these problems that climate change and continued resource development are creating for future generations. So Quebec fires was a very dramatic example where our friends to the south were suddenly very aware of forests and the warming temperatures causing forest fires. There's a biodiversity crisis. There's a need to turn that story around somehow. The Libyan dam break flood was a story of a hydrology with a civil infrastructure failure that led to the loss of life for a number of people in this community. Western and Northern Canada heat wave dominated the story the last summer. This was from 2022, the European drought. The Loire River is dried up. And then the Greenbelt debate was raging over the last year, and that also can be considered an interface, right? Somehow to protect the natural world from a growing city of Toronto. So what do we do? Well, we work and study in a variety of fields, but I would group them this way. So energy and climate change is a big one. Water resources is very important. Pollution and restoration. Environmental modeling and data analytics is a bigger field than ever. And then sustainable cities is a big part also of what we do. What would you learn as an environmental engineer? So just as Jen was mentioning or describing, we have a range of learning techniques, I guess. So, traditional lectures are certainly still there, but as much as possible, we try to get out in the field. We try to get in the lab, get your hands on doing things. I'll talk about co-op later because that's also a big part of our learning, of people's learning at the University of Waterloo. And then just a few examples of final year projects that, so these are 8-month projects that groups of 4 students will work on. So there could be a sustainable river restoration to mitigate floods. So that's the type of project that I've certainly supervised in the past, and we have lots of great examples. Designing alternate energy and water harvesting strategies for remote communities. Wetland design for water quality treatment, and wastewater sludge for hydrogen fuel use. So just 4 examples, but give you some idea of the breadth of what students are doing. what courses do you take? So I can't go through all of them. The program is available, so I think the link was just put up there. But there's some up-year electives that could include things like energy conversions, which I think is a really interesting course, environmental modeling, hydrology and hydraulics, air pollution control, design of urban water systems, environmental toxicology, ecological risk assessment. If you're not quite sure what these things mean, I encourage you to go to the calendar and read the descriptions, and because yeah, the things you can get into are really quite interesting. So we have 3 specializations at the moment, where we're looking to add a couple more, but 3 specializations in energy, hydrology, and pollution treatment and control. And then, as Jen described, there are some options outside the department if you want to focus on AI, for example, or think about management sciences as part of your degree. So what areas could you work in? There's many possibilities: consulting firms, energy sector, government, green tech, AI and software development, manufacturing, public health, international development, banking, financial work, and of course, grad studies and professional degrees. So many options available to you through this program. These are just a few kind of overview slides. So why choose this program? So relative to other programs at Waterloo, these are the smaller engineering programs. The class sizes are 30 to 80. I don't know if it's always within that range, but certainly most of your courses are probably within that range. We do have direct entry, so when you come in, you will be admitted directly as an environmental engineer. Your spot is available for you through the full time of the program. We're not looking to weed people out or anything. We're here to support you through the program. The co-op, if you're not aware of the co-op program at Waterloo, I encourage you to look that up. That's a huge part of education at Waterloo and really helps the students, I think, stand out when they finish their undergrad degree, which is why so many of them quickly move into good positions once they're finished. It also of course, helps pay for your education as you go through the degree. You do get to learn across disciplines. Both of these programs, there's relatively commonly, you'll be taking courses outside of an engineering or your particular program cohort. So you will be in environmental sciences or earth sciences or various departments. There's a few award-winning instructors that I can highlight that are on the next slide. There's an increased emphasis on design principles right from year 1. So that's really something we're trying to focus on. We're trying to integrate lab and field-based learning, and a big plus for any engineering program is that you are qualified for a professional engineering degree. So that sets you up well for a career as a PEng. And then unique to GeoEng is you can also qualify as a professional geoscientist. So there are 2 professional designations you can obtain through the GeoE program. The 1A term is pretty common, and it's really pretty similar. You'll find in many universities. The course names are familiar probably to you: chemistry, calculus, linear algebra. But also some things like environmental and geological engineering concepts is our first design course, and other things such as computational methods, electrical circuits and instrumentation. So you're getting a little bit towards the specialization, but the courses really differentiate starting in the 2nd and 3rd years. So GeoEng focuses on geotechnical and earth science courses. Environmental engineering, you'll have more chemistry, more biology, air quality type courses. There'll be some common courses in upper years. There's some overlaps, but each program would have 6 to 7 tech electives to specialize, and 2 to 3 kind of complementary breadth style electives. So yeah, as I mentioned, we're trying to combine theory and practice as much as possible. This is not just a lecture-based program. So there's modeling and testing in the courses. There's something called design days, which are really outside of the mark part of your education, and really just meant to be fun chances to work on a project and work on a problem within a day or two, and do something, get your hands dirty. Literally, as you can see, people working on a wetland landfill. No, this is a landfill design, I think, that they're building inside of a small tank. And there's other design teams. So yeah, I encourage everyone to get involved with some of these design teams, like Concrete Canoe, or other people are involved with a solar car. There's a Habitat for Humanity group, Engineers Without Borders, Women in Engineering, World Environment and Resources Council, Environmental Engineering Design Competition. So these are all opportunities to kind of enrich your degree as you go through. These are some of the award-winning instructors. So you'll meet most or some or most of these as you go through. So Rania Al-Hamoud, Nadine Ibrahim, Bob McKillop, Corey Zarel, David Brush, Wei Chow. These are all people that are well recognized for their teaching abilities. And so they really help students get used to the university environment and help you succeed as you adapt to a university style of education and a university lifestyle, because of course it's very different than what you've experienced through high school. All right, I think, Abby, we're ready for questions.
Wonderful. Thank you very much. Before we jump into our Q&A section, I do just want to highlight a few additional ways to connect with us, learn some more information beyond this webinar. First and foremost, we run chats with our engineering student ambassadors. So that's a great way to connect with our current students, ask them about their programs and things like that. So I definitely encourage you to check that out. We also have shadow days where you can come and shadow some of our current students that kind of experience a day in the life as an environmental geological engineering student. As I mentioned earlier, enginfo@uwaterloo.ca is our email address if you ever want to get in touch with us, get in touch with the admissions team, or ask any questions that you might have. We're happy to answer them anytime. And we also run tours of our facilities, and we have lots of events that happen throughout the year. So I encourage you to check those out. Our next one will be March Open House on March 23rd. So if you're in the area and you're able to make it to campus, we would love to see you on campus. So I'm going to go ahead and stop sharing my screen, and I'll encourage our panelists to turn on your cameras. And if you have any questions for our faculty or our current students, we'd be happy to answer them now. But first and foremost, I'll let the current students introduce themselves. So if you want to share your name, program, year, all that great information, and also what drew you to your program. If you can think back to when you were in high school, looking for what programs to apply to, what led you to applying to your program and ultimately going through with that program. So let's get started with Kasturi.
Hi, I'm Kasturi. My preferred pronouns are she, her. I'm a fourth year environmental engineering student in my 4B term right now. Thinking back to why I chose environmental, so both my parents are engineers. My dad's a mechanical, my mom's a civil. And I feel growing up, I was very interested in civil and like all the stuff that my mom does. So I think I was very sure I was going to do civil. And when I was looking at universities in high school, Waterloo really popped up because of its co-op program, which is so fantastic. And then when I was looking into the CEE faculty, I learned more about environmental engineering, which is something I'd never heard of before. And when I read the description, I realized, yeah, there's a really big need for environmental services, especially in the future, especially with climate change, global warming becoming such a huge problem that's affecting people. And I realized I wanted to do something to help out. So that was the reason I picked environmental engineering. And I think I've really, really enjoyed the program. Yeah.
Wonderful, thank you. And I'm sure we'll get into some of your some more of your experiences in the program. Jeff, if you want to introduce yourself.
Hi, yeah, my name. I'm a 4B geological engineer. Got me into this program. Well, just engineering in general was just high school mainly, grade 12. I really enjoyed physics. I loved all the sciences and the mathematics, and I actually got to take part in a model rocket building competition. So I know like that was a very fun experience for me, and my physics teacher was actually an engineer, kind of piqued my interest on that. So I knew about the in general. But my dad was actually a geo, kind of grew up learning about rocks and the earth and subsurface. And so I kind of just, I didn't even know the program existed because there was just, it's very niche. But when I saw it, I just knew like this is a very good opportunity and a really good chance to kind of combine my interest in engineering along with geology and earth sciences. Yeah.
Absolutely, thank you. Definitely sounds like it was a great marrying of two interests. So let's jump into some questions. I know Jen and Bruce went over kind of the courses that you take in your programs. So how about we touch a little bit on what your favorite courses have been? You know, you're in your last term now, so thinking back all the way to first year until now, what have been some of your favorite courses? Let's maybe start with Jeff this time.
Yeah, I would say probably it's a tough one. There's a lot of different courses. First year was very general and pretty difficult. But I definitely think I probably enjoyed I would say fluid mechanics was definitely an interesting one. I definitely enjoyed calculus. I thought that was very interesting. Once you get into the upper years, though, things get a little more focus on like your actual degree, and so that's when I think it gets quite interesting. I really enjoyed the geology course. And for me, I think one of my favorites was would have to be igneous petrol. Very interesting combination of the lab work, observing what you see in the lab and kind of combining, which I found very interesting. Yeah.
Yeah, thank you. And have you chosen to do any of those specializations that Jen touched on, or did you keep your degree more general?
I get my degree overall general. I kind of touched on a little bit of everything in my degree. Yeah.
Okay. Yeah, and Kasturi, I just want to add one thing, another question that came in. They're wondering what sort of opportunities there are for hands-on experiences for environmental engineering students, such as going into the field and building things. So maybe as you talk about your favorite courses, also touch on what sort of opportunities there are for that.
Yeah, sure. I think it actually ties in well to my answer because two of the courses that come to mind when I think of my favorite courses are actually stuff that had a lot of lab work and field work in it. The first one is something we take in 1A with Bob McKillop, which is our Intro to Environmental Engineering, the Environmental 100 class. It's definitely a very interesting class. You learn a lot about just being in university. I feel it's like half life lessons, half intro. And it's a very enjoyable course. A big part of the course was us learning to survey on field. So that was our first time using all of those equipment, being outdoors for hours at a time, being on North Campus, surveying the area, actually putting it down on a map, and then also learning how to use AutoCAD and plotting all of that, making a map of North Campus. It was a lot to learn within 4 months, but I think that set us up very well for being able to apply for co-op immediately because we were on fourth stream and had to apply for co-op positions right out of high school. And we were very lost, scared, and Professor McKillop was kind of like, you'll know what to do once you start your job. So I feel that course was definitely very helpful. The second was with Professor Bill Annable, Advanced Hydraulics, which I think we took somewhere around third year. But yeah, that's also a very interesting course. We get to work in some group projects, have a few labs. These labs were not outdoors. I think he also has a class where he has taken us outdoors multiple times for labs, but this is his second class. But yeah, that was very interesting. And I think my favorite out of all of my classes were geotechnical engineering by Professor Basu. Absolute standout. He is an excellent professor. That's the reason I went ahead and took Geotech 2. He is on sabbatical right now, so I'm very sad I can't take Geotech 3 this semester. But yeah, I think having really good professors in our program makes a huge difference on like how much we learn as students. Yeah.
Yeah, thank you. That's fantastic to hear that you've had such good experiences with your professors as well. And Jen, I know you get to go on a lot of field trips with your geological engineering students. So do you have a favorite field trip that you might want to highlight?
Yeah, I think So it is tempting to pick the 10-day field trip as my favorite because we get to go up north and so around Sudbury and spend a lot of time just sort of hiking, which is a really fun thing to do. But I think my actual favorite field trip is a course in a course called mineralogy, and it's just a 2-day field trip. So we just go up to Bancroft, which is just about a 4-hour drive from here, and we just go, up one day, we stay overnight and come back the next day. But it's the first time a lot of students have actually been out in the field, and up to then they've sort of been in labs, and we'll give them little samples of rocks and we'll kind of look at them. But getting them out in the field that first time is just great, and it's it's a huge learning experience for everyone. And sometimes the weather isn't great, and they do have work to do, and it's kind of like a busy day, but then they come back and they really have this sense of accomplishment, and they all are like, they just feel like they're getting closer to kind of like their end goal. So having that first field experience with the students is definitely my favorite for sure.
Amazing, thank you. And Bruce, do you have a favorite course that you get to teach, or favorite kind of field trip that you get to do with students?
Well, I'm teaching design of urban water systems. Right now, it's a 4th-year tech elective course, and that one I like to teach. It's very, I would say, a practical one because it's really focused on modeling skills that students use right away. Some of them actually have done the type of work we do even before they've taken the course, and they're happy to kind of backfill their knowledge a little bit. But we're trying to use the campus as our living lab. So we're working on retrofits for campus that we can design that would help make the campus more sustainable. So that's really fun. This year we're doing it in a joint delivery format that we haven't tried before, but we're doing it with a planning course so that planning students and engineers are kind of looking at the problem together and talking about it. And we have somebody from the city of Waterloo that's going to talk about what they're doing for stormwater management. So we try to, get people working as close as possible on real problems, right? So that's really fun.
That's very exciting, and I think definitely an exciting part of undergrad is to get that real world experience. So that's great. And so Kastori mentioned co-ops, so it'd probably be great to center in a little bit on that as well. So for those of you who might not be familiar, all of our engineering programs are co-op programs, and co-op is another word for internships. You might be more familiar with them referred to as internships, but basically how co-op works is you start right from first year, so kind of circling between or going back and forth between academic terms and work terms. So for 4 months you study, and then for 4 months you go out and do a co-op work term. And you do that right from first year all the way until your final year, switching back and forth between study and work terms. So really getting to learn new things and then apply new things and gain that real world experience. So Kastori, maybe we'll start with you. I know you mentioned you were stream 4. So again, those of you who might not be familiar, stream 4 means that you do 4 months of study, and then you start your first co-op work term right in your second term. And as Kastori mentioned, that can often be quite intimidating for students because you're just fresh at university, and you got to start thinking about co-op jobs. But I know, Kastori, you mentioned that your courses really prepared you for that. So what did your co-op application process look like? And then now that you're in your final, of experiences have you had?
Sure. My co-op application process was heavily dependent on like a law Waterloo. Coming out of high school, of course, we've never had formal internships. Um, it's very intimidating to apply, but Waterloo has a lot of resources. You have, back in our time, pre-COVID, we had in-person interviews, which obviously was scarier for first years. But we had all of these sessions at Tatum Center where they kind of reviewed our resumes, gave us training about how to like go about an interview. We had so many resume critique workshops run by Engineering Society, various first-year residences, and even our RAs or TAs. So I think that was definitely a process of making sure that your resume was up to date all the time. Sorry. And sorry, I lost my train of thought. And yeah, so I think it was a lengthy process. I think people don't understand how many jobs you need to apply to get interviews and actually turn those interviews into actual jobs. I feel I applied to 20 in my first round and I was like, why is no one calling me back? And then I feel by the end of my sixth co-ops, we were applying to like hundreds every single semester. And we're like, this is just normal behavior. So it's understanding that you really need to be very persistent and keep applying and not really feel deterred by rejection. Now that I've completed six co-ops, I think it's absolutely like I would recommend everyone to have co-op experience in their pocket. It makes a huge difference, and you can see that when you compare Waterloo interns to interns from other universities. A lot of the Waterloo undergrad students are a lot more mature, have a lot more experience about how to behave at a workplace, what the client is expecting, what your coworkers are expecting. And it definitely gives you an edge when you're applying to full-time job opportunities. And I'm going back to one of my old co-op employers. I'm very happy about it. And I don't think I would have realized that I am interested in that field of work unless I'd done a co-op. It was a chance job that just happened. COVID was a very tough hiring market. And I ended up jumping at the job opportunity during that time. This was back in 2022. And I ended up really loving the job, really loving the company, and I decided to go back. So yeah, it's a really good program and highly recommend it for everyone.
Fantastic. Thank you for sharing. And definitely, I went through the co-op program myself, and you definitely kind of become a master of that job application process with creating a resume, submitting to the hundreds of jobs, dealing with the rejection when it doesn't work out. But definitely by the time you go to graduate and apply for that big time real world job, you're very well prepared for that. And before we move on to Jeff, I just want to ask, what positions did you have over your six co-op terms?
Ooh, that's tough one. The first one was a junior software developer because I took coding classes back in high school. The second one was a junior energy consultant in a firm in Waterloo. The third one was a TA for one of our classes, MATLAB coding. The fourth one was project management in civil transportation. The fifth was a mechanical support member for like a wind turbine de-icing system manufacturer. And then my last most recent one was a solar design engineer. Yeah.
Great. It sounds like you had the opportunity to try out a lot of different things, which is another great thing about co-op.
Yeah, it's a very broad range of things that I tried, and I'm going back to the civil project management.
Fantastic. Congratulations.
Thank you.
And Jeff, what sort of co-op experiences have you had?
Yeah, so I've had like a pretty wide range just in general, in terms of like my actual technical skills and what I've gotten. The first one was actually more of a mechanical engineering job that I got in my first co-op. So that was very interesting. I actually moved to a new city. I moved to Barrie. I lived up there. It was definitely a really big challenge, and very intimidating for a first year. But I ended up learning a lot of it project management, and even just general like engineering competencies, organization, which is actually really big in the course. After that, COVID hit, so it kind of got difficult, but I was able to get a job with a junior exploration company, mining company. So I started to really get like a hang and learn about geology and how it's applied in the field, which I actually really enjoyed. It's really fun to be out in the field and just see how the actual aspect and science of geology is applied in the real world. So that was great. And then a couple more co-ops working as a geologist. I decided to get more experience as an engineer. So I got to work actually at a mine site as a ground control engineer, which is very exciting. I got to go underground into the mine, yeah, and ground control turns out is super important. There's a lot of issues down there in the mine, and so it was really amazing just to be a part of that. When I was just like, just a university student, it's so important. And then my last job, I actually got to work for a mining company downtown Toronto. So I was working on the mine planning team, which is really great. And I kind of got to extend out into some financial applications, which is very interesting. And it's actually also very important as an engineer, is kind of combining the economic analyses with uh, your your regular engineering technical skills. So yeah, definitely got a wide range of skills from my co-op experience. And it's definitely very intimidating when you first start at university, looking for a job and working in the real world. But I think that really sets you apart from other people. You confront it early on, and then the world kind of opens up to you, and you have a lot of opportunities.
Absolutely, yeah, definitely that idea of confronting it early on is great. And you know, you think about the graduates who don't get that co-op experience, don't get that internship experience, then after their 4 years, they're thrust into the real world with not a whole lot of preparation. And so that thought of confronting it earlier on and getting over that hurdle with a lot of support from the university as well is great. So as we talk about co-op, another very common question that we get, both for co-op and after graduation, is what the pay scale looks like for an environmental and geological engineers. I think a common, perhaps myth that I hear is that there's not a lot of money to be found in these fields. Does anyone want to comment on that? I'll just kind of leave it open to anybody.
I don't want to reveal my actual pay, but at the same time, I will say I think when I started, I was making solid minimum wage at the time. And that's fair. Like your first co-op jobs are always slightly lower paying because you don't have a lot of experience, and you take a lot out of the experience than you actually add to the team because you're very young, you're learning a lot, and they will use a lot of resources to train you. So it's like 4 months of training and then you're gone. So the first co-op is usually pretty low pay, but I will say that my pay has increased like consistently over every single co-op semester. Um, I think when I see the average range of co-ops that people make, I think for the first three co-ops, I was like reasonably within the average. And then the last three co-ops, I was towards the higher end. Um, and I think for my last co-op, I was like above the range. So I don't think it's true that there's not a lot of money. It really depends on the positions that you work in. Of course, like things like project management, things like financial analysis, there are certain like positions that obviously make a little more money than typical engineering positions. But it really depends on your interest, and I think long term it evens out. And once you start your full-time position, if you work in the company for a few years, the average pay will always be the same with most other engineers other than software that we cannot compete with.
Yeah, thank you so much for sharing those experiences. Did anyone else want to comment on that sort of myth that gets tossed around?
I'm sure, I don't know if Jeff can comment on how much relatively he's made for co-op positions. And I wish I had some data, which unfortunately I don't have data, but I think that's a complete misconception. I've been told that geological engineers are some of the best paid right out of school. But I don't have any data to back that up, and I also can't give you a number. But I will say that we're highly employable. We do quite often have small classes. A lot of our geo-engineers go back to co-op employers. On Tuesday, we had a consulting company fly 2 employees from Vancouver to Waterloo to do recruiting at our school for geo-engineers. And some enviro engineers as well. And yeah, I think our graduates are getting snapped up as soon as they graduate. The folks that don't have a job when they graduate, it's usually because they want to travel a little bit before they start working. But my impression of, sort of working in this field and seeing students graduate from this program over the past many years is that they're well paid, and they are very well, I shouldn't say it's easy to get a job, but it's definitely an employable field.
Yeah, I have a slight ability to back up Jen's, because I do remember exit surveys. And sometimes they do exit surveys and they report them to the department. So I know environmental engineers usually comes in on par, as Katsuri was saying, with other, or Kasturi, sorry, with other engineering. But geo, yeah, tends to be a little bit above. And there are fewer of them, and I think the competition may be high for their services. So they tend to have slightly higher salaries, or yeah.
I would like to add on that there are certain roles within enviro and geo which are slightly high liability, especially like geotechnical engineers, certain like environmental assessment engineer like positions, and with the high liability comes a higher pay. So that's always a trade-off you give and take. The other thing is I feel also towards the end of your co-op semester, especially the last 3 co-ops in your full-time, a good skill that we learn is negotiating. I feel the first 3 co-ops, whatever they gave, I took, and I was like, yes, okay, thank you. But towards the end, I started negotiating aggressively, and it definitely paid off. I feel that I would go like really highball the companies, and HR would say no, and I'd be like, okay, we're going to talk, and it ended up paying off. And I feel Waterloo offers a lot of support for that. They have workshops where they teach you how to negotiate, how to approach these conversations, and I think that sets up for a lot of success in the work field, because when I talk to people from other universities, they usually never negotiate, and it's very surprising. So yeah, that's definitely a skill that we pick up in Waterloo.
Yeah, absolutely. Thank you all so much for that. And definitely we have lots of data on our website and things like that as well if you're looking for those specific numbers. But I can absolutely echo what folks have said anecdotally that these are definitely, I think that myth is a myth. And I mean, especially when you think of how specialized these roles are, especially with geological engineering. If you need to hire a geological engineer to do something, there's not a whole lot of selection out there. So you have that power of negotiation, like Historia was saying, that you can say like, okay, you need to hire a geological engineer. This is kind of my rate and things like that. So we're kind of nearing the end of our webinar, but I want to get a few final thoughts. Just generally thinking about prospective students, who would you recommend to either environmental geological engineering? If like what sort of subjects in high school do you think would they be a good fit if they enjoy for these programs, and why would you recommend these programs kind of overall? So let's get started with Castoria maybe.
Sure. I feel like the subjects you need to love if you want to be in engineering is math and physics. It's the basics. It's always there. It's always hovering over our heads in every single course we take. If you're taking environmental, you need to have an inclination in chemistry. I didn't, which was very surprising to me. But at the same time, I don't think it's anything that above and beyond. So as long as you have an interest in the general sciences, you will be fine. To pursue environmental engineering, though, I feel like you should have a genuine interest in environmental and wanting to work in this field, and also like being outdoors. We have a lot of outdoor labs, we have a lot of outdoor activities. There's 2 summers that we are supposed to be on campus. We missed one of them due to COVID. Jen, it was your class, and we had to look at pictures of rocks on our computers. It's really sad, but I know if we took it in person, we would have a lot of outdoors time. And same for the next summer that we took with Professor Annabelle, we almost were outdoors for like 8 hours straight in labs every week. So it's important for you to enjoy that interaction with nature, not feel too creeped out about it. But yeah, I think as long as you're interested in your basic math, physics, chemistry, you're going to be fine.
Yeah, thank you so much. And definitely always good. I think students think that they need to be good at all of those subjects, like you were mentioning chemistry and stuff. You don't necessarily need to be naturally good at those things. It's okay to work hard to be good at those things, and as long as you have that enjoyment for it, like Historia was saying. Jeff, what are your thoughts on who would you recommend geological engineering as a high school student?
Yeah, definitely like if you do have a geology course in your high school, like, it's unlikely. But if you definitely, yes, definitely an inclination towards physics, mathematics. I would also say chemistry is important. We don't touch on chemistry like a lot, but definitely kind of that interest in the physical world. I took biology. I was very interested in that. That's partly because I was definitely interested in the natural sciences of things. And yeah, I enjoyed learning about that type of stuff. My mom was actually a biologist, so she spent a lot of time out in the field. I was definitely very interested in the outdoors, and not even just courses in high school, but also like things like clubs. I was actually part of the outdoors club, so at high school. So it's just kind of being interested in that kind of area of things is definitely important. So yeah.
Yeah, that's perfect. I definitely think it's helpful for high school students to maybe hear these traits and think, oh, yes, I love all those things too, and hopefully feel reassured in these programs. Bruce, did you have any thoughts for our prospective students?
Well, I was similarly interested in natural sciences and whatnot, but I think with engineering, the key for me is that you're going to be asked to solve a problem, so that if we need solutions to so many things. So environmental engineering might not be obvious, right? You're not designing a drone perhaps, but maybe you're designing a process, right? It could be a chemical process, or it could be some sort of a device that would improve something, right? So it's still engineering in that you're trying to use your knowledge to figure something out and propose something new. And I think that always was what appealed to me the most, was this idea of building up all your knowledge, sure, but then doing something with it, and trying to fix something or improve something, or do something. So I think that's an important trait, right? If you're curious about stuff and you're trying to figure things out, it's a good spot for you.
Yes, that's a fantastic point too, that engineering curiosity, that inclination towards problem solving is such a big part of kind of at the heart of any engineering, and environmental and geological engineering included. I know when I talk to engineering students, I'm not an engineer at heart, so I often talk to engineering students and say, why is this something that you enjoy doing? Trying to understand that. And they talk a lot about that curiosity and the problem solving, and maybe watching documentaries about the climate crisis and thinking someone should really do something about that, and being inspired to be that person that does something. That's what I hear a lot of. And Jen, you get the final thoughts. What do you want to share with our prospective students?
So I think everyone did a great job on kind of touching on sort of like, what kind of things you're interested in. So I will just kind of add two quick things. First of all, I think in geological and environmental engineering, you have to have the ability to kind of think about a lot of things at once, because you need to think about that whole sort of engineering design side of things, so that the math and the physics, but then you need to bring in all of that knowledge about that natural world. So whether it's the earth, for geoeng, or like biology or chemistry, works for both geo and environmental engineering. So it's not, you have to be able to think about how to kind of find the best solution, and kind of analyze a lot of different types of data sets. So I think kind of like bigger thinking is inherent. And I would also say that the kind of person who should apply to geo, but also environmental engineer, are people who are interested in getting involved in a really great, tight cohort. We do have really small classes compared to the bigger programs. And so you'll really get to know your classmates really well. You'll get to know profs. They'll teach you many different times. And so we kind of get this really great, tight-knit kind of community, not only like within the students, but, between the instructors and the profs and the students. And, I walk around the buildings in Waterloo and run into Jeff frequently, or other students in GeoEng, and we'll stop and have like a 2-minute conversation. And, that's not going to happen in software engineering. So if you want kind of that smaller like community feel, then I think these are the programs for you.
That's great, and definitely a good point to highlight as well. We mentioned it briefly in the presentation, but it's really one of the things that I think a lot of students in geological and environmental engineering especially get to benefit from. So thank you all so much who are able to attend today, and those of you who might be watching the recording afterwards as well. If you do have any other final questions that either you're thinking of now or that might come up later, feel free to email us anytime. Continue connecting with our students, and hopefully we'll see you on campus soon. Take care, everyone.
Thanks, everyone.
Bye-bye. Thank you so much.
Everyone.